So recently, we've been doing a lot involving p-values. Whenever we run a hypothesis test, we get a p-value, we discuss it, we link it to alpha. But let's actually take a couple minutes and talk about what a p-value really is, okay? So let's say we have a scenario. It's believed the average weight of fish from a lake is 25 pounds with a standard deviation of 9, okay? So we have our average is 25. We have our standard deviation is 9. Over your life, you catch 36 fish that have an average of 22.5 pounds. So if I were to draw this curve out, so for right now, let's just say that this is true. This 25 really is true. Okay. All right. And we got an average. So when you caught the 36 fish, average is 22.5. All right. And what we're going to do to find the p-value here is that I want to get the area of this tail right here. Okay. So what a p-value is going to tell us is that let's say this 25 really is true. Obviously, we got less than the 25. So the p-value is going to tell us if this 25 is true, what are the chances of us getting 22.5 or less in this case? So let's go ahead and figure that out. So my z-score right here, we're using z because we know the population standard deviation. All right. So you're going to do 22.5 divided, not divided by, minus 25, divided by 9 over root 36. So just to crunch this really fast, this is negative 2.5. 9 over 6 is going to be 1.5. All right. To put that in simplest form, that's 5 over 3. So it's going to be negative 1.67. That's our z-score. Okay. So if I were to make a second axis right here, all right, so our z-score is negative 1.67. If I go look at a formula sheet and figure out what that p-value is, so negative 1.67 is 0.0475. So that gives me an area of 0.0475. All right. So that is telling me that once again, if 25 really is true, the probability of me getting an average of 22.5 or less is 0.0475. So here's what's going to happen. Let's say that your friend does the same thing. He catches 36 fish from the same lake. Let's say he gets an average of, let's say 24 instead. Okay. So your second friend, so we're going to say, so the average is still 25. All right, standard deviation is still 9. But let's say now your friend gets an average of 24. So here's what should happen. Because this 24 is closer to the average or the supposed average of 25, it should have a larger p-value. Okay. The area should be bigger. Okay. If I'm drawing it on the same scale as the one before, 24 is going to be over here somewhere. Okay. Making it should be a larger area. We should get a larger p-value. So if I'm going to crunch this, it's going to be 24 minus 25. Same thing. He also got a sample of 36 fish. So that's going to give us negative 1 over 1.5, which is negative 0.67. All right, I go look on my formula sheet. The tail area of negative 0.67 is 0.25. All right, so now that's his p-value. So if the real average is 25, the probability of getting an average of 24 or less when you have a sample of 36 is 0.2517. Now, here's where the whole idea of level of significance comes in, okay? Obviously, the closer we are to the average, the supposed average of 25, the larger our p-value is going to be. Typically, the level of significance is 5%. Sometimes it's 1%, okay? But let's just say 5% in this case right here. If you get a p-value that is less than that 5%, that means that you have a legitimate claim that the null hypothesis is not true. In this case, our null hypothesis would be checking that this 25 really is the average. So looking at two different scenarios right here, you get an average of 22.5. That produced for it. So that was far enough away from this average of 25 to produce a p-value of less than 5%. So based on your sample, you do have a claim, a legitimate claim, that the average really is less than 25. Now, let's say you only had your friends, all right? Theirs is much closer to the mean, and they have a p-value of 0.2517. That is not enough evidence. That is not far enough away from the mean. Because remember, his 24 is much closer to the mean than your 22.5. Okay, so in this case, if you only have a sample average of 24, that is not enough evidence to claim that 25 is not the average. Okay, so in a nutshell, that's what p-values are, and that's what they have to do with alpha. So just remember, you want your p-value to be small. If your p-value is smaller, that means that you have a claim against the null hypothesis, because as this tail shrinks, you are getting further and further away from the hypothesized value.